In this video, let us continue to solve more problems based on the application of the sine rule in the problems of heights and distances. So here we've got one such problem. Alright, so here is the problem which reads like this. It says the angle of elevation of the top point P of the vertical tower PQ of height h. So this height PQ is h. From a point A is 45 degrees, and from a point B, here is point B, the angle of elevation is 60 degrees, where B is a point at a distance D from the point A measured along the line AB, which makes an angle 30 degree with AQ. So prove that this D, so D, I hope you got it, the D is nothing but it's the distance between from A to B. This is D, alright, and then AB makes an angle 30 degrees with AQ. That's what it says, the line AB which makes an angle of 30 degrees with AQ. Now this is the thing. Now it says prove that this distance AB, which is equal to D, is equal to root 3 minus 1 times the height h here. The PQ is h here. Alright, so let us see how do we go about solving this problem. Now it is given that PAQ equals 45 degrees and BAQ is given as 30 degrees. So therefore angle BAP should definitely be equal to 15 degrees, right? 45 minus 30 is 15 degrees. So angle BAP will be equal to 15 degrees because we are to get the angle BAP, which BAP, we just need to subtract 30 from 45. You get this angle. See, I'll just mark it here on it. Okay, the green one here on top of the black, which is marked. So that is the 15 degree angle. Otherwise, you join this black and green, it becomes 45. Alright. Now, let us consider the triangle AQP. Alright. Let's consider the triangle AQP, which is a right angle triangle. You know, as you can see, this is 90 degrees here. Right. So, if this is 90 and this is 45, this should definitely be 45, right? So, we'll write in triangle PAQ. In triangle PAQ, we have angle PAQ as equal to 45 degrees, right? PAQ is equal to 45 degrees, and angle PQA, that's the right angle, so it's going to be 90 degrees, PQA, and then we have angle APQ, which should be 45. If this is 45, this is 90, this obviously has to be 45, right? So that's going to be 45 degrees. Now let's consider the next triangle. And then now in triangle BRP. So in triangle BRP, we have PBR already given, which is 60 degrees. Alright. And then angle PRB. This is, again, it's going to be a right angle, right? Is the 90. So angle PRB is going to be equal to 90 degrees, and then therefore now as a result of this, angle BPR will be 30 degrees because you've got 60 and 90, which makes 150. 150 add what to make it 180? Add 30. So therefore BPR, angle BPR equals 30 degrees. So we've got these data. Now we've got this one and we found out this one. All the other angles were already there in this, you know, we didn't have to like find out as such. So what's the next step now? So before I go to the next step, let me tell you what we're going to do from here. You know, why have we done these? You know, if you're wondering why we've done this, the reason we're doing this is eventually get all the three angles of this triangle, right? Once you get the three angles of this triangle, you know what happens once you get the angles of the triangle. You can use the sine rule straight away. And especially, you know, we need to prove that D is equal to something. So it'll really be useful when we have all the angles, right? So once we have the angles, that's what we can do. So that's why, you know, once we find these angles, we can definitely find this angle. So just see, we've already got one of the angle, that the green one. We need to get this side. Again, it's not a very difficult task because we just have to subtract the bigger angle and the smaller angle. The bigger angle is this, from this point to this point. The smaller angle is from this point to this point. So what are they now? So we just have to do, now angle BPA is what we need, right? Angle BPA. This is what we need now. So angle BPA is nothing but angle APQ minus the angle BPR. APQ minus angle BPR. So APQ is 45 degrees, BPR 30 degrees. So therefore, we've got angle BPA as equal to 15 degrees. So we've got this one now. We have to go to this triangle ABP. In triangle ABP, we have two angles. It's very easy to find the third angle. We have this is 15 and this is 15. If this is 15 and this is 15, angle ABP will be what? Angle ABP will be equal to 180 degrees minus 15 plus 15, which is 150 degrees. That's because this part, which is equal to 15 degrees, and then this part, which is equal to again 15 degrees. Therefore, this will be equal to 150 degrees. Alright. The next step is, now we need to use the sine rule in triangle ABP straight away. So using sine rule in triangle ABP, we have this. So now using the sine rule, we have, let's start off with AB. AB divided by sine of the opposite angle. The opposite angle is 15 degrees. Equal to BP divided by the sine of the opposite angle. Again, it's 15 degrees. Equal to AP divided by sine of the opposite angle, which is 150 degrees, right? So now AB is D. So let's replace that by D. And sine 15 degrees, as we did in one of the previous videos, it is equal to root 3 minus 1 divided by 2 root 2. So D divided by root 3 minus 1 divided by 2 root 2 equals, now let's not take BP because it's not going to be of much help to us. We just need to consider two things. So let's take AP by sine 150. So AP divided by sine 150 degrees equals half. Please use the concepts that we did in the previous videos to calculate what is sine 150 degrees, which is equal to half. Okay, and then, so for now what we'll do, we just find out what is AP. AP will be equal to, just cross multiply and you solve this. You have AP as root 2 of D divided by root 3 minus 1. Alright, let's keep this as equation 1 and this is AP for you. Now, if you look at the question, we have to prove that D equals root 3 minus 1 into H. We haven't still got H in the picture here. We need to get that as well. Now we need to go to another triangle. Now straight away what we'll do is we will use using sine rule in triangle AQP. The reason we are doing that is to involve this H, right? Otherwise you're not getting H in the picture anyway at all. You just have to do this. That's the only way you've got. So in that case, let's take first AP. AP divided by the opposite angle is sine of 90 degrees. So AP divided by sine 90 equals AQ. Equals AQ divided by the opposite angle is 45 degrees. Sine of 45 degrees. Equal to, then the one side left is PQ. Again, PQ divided by the opposite angle is 45 degrees. So it's sine 45 degrees. Now what we have to take though is, let's take AP and PQ. The reason we are taking AP and PQ, because we have an AP here. That's why we are not taking AQ here. So AQ here and BP here are like, not really useful. So we are taking AP by sine 90 equals 1. So AP equals PQ is H divided by sine 45 is 1 by root 2. Alright. So now from this we have AP equals, reciprocating this, you get root 2H. So AP equals root 2H. Right. So now consider this as 2. So now what we have to do is, looking at 1 and 2, both are AP. Here AP is equal to this, here AP is equal to this. So equate these two now, right? So all that you have to do is root 2D divided by root 3 minus 1 equals root 2H. So keep D to the left hand side and push everything else to the right hand side. That's all you have to do. So now what happens? D equals root 2H into root 3 minus 1 divided by root 2. The root 2 gets cancelled. All you've got left is D equals H into root 3 minus 1. So we proved here. So that's all that you have to do. I mean, it's root 3 minus 1 into H, but here it's H into root 3 minus 1. So that's all there is to solve in this problem. Well, it may have been a little complicated because, there were a number of triangles involved. It may not have felt really straightforward, but trust me, if you know the application of sine rule, and if you know how to get in those required alphabets and all those things. For example, now in this equation we had got the D, but we didn't have the H. So how do you get in H? You have to, when we do sine rule, it's pretty simple. Take the triangle, apply sine rule, and sometimes you don't have to use all the three, you just have to take the two. And why do you choose AP? Because, we've got AP here, we can equate. So those are the kind of things, that's the way which you got to think, and that'll come by practice. So as far as this problem, it is done. This is how it has to be done. And this ends this video as well. I'll see you in the forthcoming videos with more problems based on application of sine rule and heights and distances.